Okay, so my name is Evgeni Dyulgerov. I will try to fit within 40 minutes. Okay, so very fast about me. I'm an IT professional with over 30 years of experience, co-founder of consulting company Digitalix, lecturer at the Cybersecurity department and the Technical University of Sofia, where I also have a PhD at the moment, focused on application of AI in cybersecurity, more specifically in the defense of critical infrastructure. Those are things like Bulgarian Postal Agency, like nuclear power plants and so on. And I'm also co-authoring with a team of authors a couple of books focused on cloud security. And here are my contact information. So what I'm going to talk about, AI in cybersecurity, some security risks for AI-powered systems, adversarial AI and what it does, securing AI and HASTAPs, MLOps in security in Azure, some bonus about AI security in critical infrastructure, and some future trends in AI in cybersecurity. I'll try to convince you that AI is actually very useful in cybersecurity in the next minutes. So why should anybody care about AI? Are there any developers in the audience? Okay, there are some. Now, as you know, some people say that AI might replace developers. That won't happen because it still doesn't operate quite well. And it won't replace cybersecurity professionals as well. However, here are some statistics. There are a lot of currently open positions for specialists with AI skills, a lot of unfulfilled cybersecurity jobs. AI-driven cyber attacks are on the rise, as I'll show later on in the presentation. AI could be used both for an attack and defense, and a lot of big tech companies employ AI-experienced professionals. For example, in Ukraine, a lot of specialists from Cisco and other companies joined the Ukrainian government in order to protect the critical infrastructure from hybrid attacks, and they actually implemented some quite innovative solutions there. Some other stats, AI-driven security tools would be a standard by 2030. Of course, there are a lot of startups currently emerging focused on AI security tools. Of course, not all of those tools actually use AI for what it should be used. Some actually just use AI for suggestions that they give to the cybersecurity professionals. Some may use it for some kind of automations where, let's just say, we have some alerts that are logged in ServiceNow or some task logged in Jira based on the information that we analyze, and some other things. So if to basically does with AI something that you can do with an SQL query, let's just say, then maybe it's not an AI tool, but there are some pretty decent tools out there. Some prognosis that AI might reduce incident response time by 96%. That's still to be seen, but with proper automation, with proper, let's say, smaller tasks, maybe we could reach that. As mentioned already about developers, we have about 30% improvement in their work, which might not be enough to replace a developer, but it's enough in a team of developers to lay off a person or two. Same with a team of cybersecurity professionals. A lot of organizations believe in enhanced security, and last but not least, there is pressure from governments in accepting some policies focused on cybersecurity, like AI Act, NIST AI Framework, and others. So where exactly is AI used in cybersecurity? It's used in anomaly detection, in network traffic, it's used in behavioral analysis, in user authentication, for automated threat detection and response, rate limiting, API abuse detection, and monitoring. Some pictures that would explain the concept better. Let's say we have a model that reads logs, and then just detect some anomalies, and it could trigger alerts or maybe generate some report for the professionals to check it and fix it. Behavioral analysis, let's say we have a senior developer who just uses some repositories and a couple of folders. So what is a behavior anomaly? A behavior anomaly is if he enters at free at night, if he, let's just say, he tries to open some folders like sales and marketing teams, folders, he tries to search for some information about the company strategy and other things that they are not part of his actual work process. That's an anomaly. And something interesting, some companies actually record their team calls and then use AI tools to analyze what's sent to the given team's call, which they try to understand how the employees feel about something, whether they're not discussing how to steal company data. I mean, that's an internal threat. Or maybe discussing whether they want to leave a job and so on. Some people might say that's an invasion of personal space, but given that those calls are related to the given job process, it's actually allowed. Some other pictures about automated threat detection and response. AI tools can scan a certain infrastructure. It could register some alerts in different systems like Jira, ServiceNow, and so on. It could create reports for the users and maybe perform some response like changing some configurations and so on. My presentation is more focused on some abstract things too, so that you can get a clear picture. There are no demos here. In different presentations, I have shown some demos about AI, but here it's more theoretical. Another thing is rate limiting, to limit the number of requests that are performed to the API so that we don't have DDoS attacks. And last but not least, we could use AI for things like checking whether there is encryption at rest and in transit, check the given privileges, whether they are properly set, monitor, and so on. So a little bit about adversarial AI and model exploitation. We got a little bit of a picture about how AI could be used for defense. Let's see how it could be used for attack. So a little bit about AI. What exactly is AI? Those are machine learning algorithms. They could be grouped in many different ways: regression, classification, clustering, and so on. When we usually talk about AI, those are deep neural networks and large language models. So here is a little bit about the convolutional neural network. I won't explain all the different aspects and the math behind it, but let's just say it extracts some certain features of data. And based on an optimal amount of features, it tries to make a prediction. Of course, we may have false positives. It might not guess the proper information correctly. In this example, it tries to extract, let's say, the edges of a number, and based on a certain number of pixels, it tries to predict what number it is. However, how can we generate an attack based on that? Well, let's just say we have a deep learning-based botnet attack detector where we analyze traffic and try to predict whether we have an attack. So what's the problem here? We can also use some other machine learning algorithms like fast gradient signing methods and others to generate adversarial examples that we could actually use to fool the model and cause him to create false positives or maybe to misclassify some attack as valid network traffic and so on. What is the picture below? There was an incident with Tesla cars that used artificial intelligence, where the model was very easily tricked. The car was tricked just by adding black tape to a speed sign that the speed limit is not 35 miles per hour, but 85 miles per hour, just by something like that. Or another example, let's say there were some good scientific articles how you can trick an image recognizer with just by changing one pixel that an image of a cat is actually an image of a frog, let's say. So these models are not very accurate, unfortunately. You can trick them. Also, Tesla might recognize some road markings incorrectly and might change lanes and so on. So, in fact, it's not very safe. How can we basically improve that attack engine? We could add generative adversarial networks where we have a generator network that tries to generate false traffic and discriminator that actually tries to figure out that it's false traffic and optimize the weights of the generate a network, and then the improved examples could be tested on the victim model, and then could provide some traffic that might actually pass our defenses. How can we defend against that? We just need to retrain our defense model with the examples that are being generated by the attack engine, and with a lot of retraining, basically, unfortunately, there is no solution that could just be installed and used, and we don't have to retrain it. Basically, the model will always fail under certain conditions. So a little bit about security risk related to AI-powered systems. Now, a lot of companies start to design some system, and security comes sometimes later into the architecture, which is costly and so on. So once we actually design some system, we need to know what are the main risks. And for that we have OWASP PMM Top 10. I'll just go to them with the mitigation strategies. Prompt injection, that's when an attacker creates a prompt that could get some confidential information from the model. We could mitigate that with input validation, sanitizing the prompts, and restricting dangerous commands. Or if we are using large language models with natural language capabilities, we could analyze what the prompt is and maybe return nothing to the hacker, or maybe just return some information that he cannot perform that operation. Insecure output handling, that's when the model is working correctly but might return some information that could lead to some legal issues with the company, some reputational damage, or might just return information that is wrong, because models tend to hallucinate and return wrong information. That's we have to validate the output. If it's a business process, we have to introduce some human in the loop that actually checks the information that is returned to the end user. Implement access control, logging and monitoring. We might have also training data set poisoning, when an attacker manages to poison our data sets and make sure that model returns only certain information based on the certain inputs. In that case, we have to validate the training data, protect the training data sets, implement input filters. Then our service attacks, we have to implement rate limiters, monitor the incoming traffic, implement input filters. Supply chain vulnerabilities, there are a lot of issues here that could occur. We have to audit the models data sets, update and patch third-party libraries, implement cryptographic signatures, monitor third-party services, implement supply chain level for software artifacts framework or something similar. For sensitive information disclosure, again, data sanitation, implement output filters, role-based access control, monitor and the output. As you can see, a lot of these defenses are basically the validations for the input and the output, role-based access control, and constant monitoring of what exactly is happening. Again, with insecure plugin design, strict input validation, authentication authorization, security audits and updates, sandboxing the plugins. Excessive agency, implement human in the loop, role-based access control, logging and monitoring. Over-reliance, that's when we over-rely on the results of the model. As you know, there are constant attempts to make the large language models as smart as humans, but we should never forget that even humans make mistakes. Therefore, we should communicate the limitations of these models to the employees that use the models, to our end users and so on, that these models actually could be wrong. So we again implement validation layers, logging and monitoring, and we implement secure development practices. I've added that because there is the issue with shadow AI. That is when certain developers use AI tools without authorization from the security team and their managers. And there were some scandals about that with some big companies, where the developers have pasted a lot of company code in, let's say, tools like ChatGPT and others, and in order for the tool to generate some code for them. And of course, that was a leakage of a lot of critical information for the company to third parties, and that was a major scandal. Model theft, role-based access control, centralized model registry, restrict access to third-party APIs, logging and monitoring, and automate the MLOps deployment. Here is how it looks all the attacks, and users could perform model theft. Training data sets need to be protected from the training data poisoning and sensitive information. Between the application services and LLM, we have to have input and output validation. We have to take care of overall alliance and so on. I won't read all of them. And just to mention, there are a lot of other frameworks that you can actually check, like MITRE Atlas, that also describes a lot of attacks and mitigation strategies. So about securing AI-enhanced applications. Here is a very small architecture about an application that uses a lot of different models and third-party applications. It's designed with Draw.io, a very cheap tool for architecture design. So let's say we have some client application, like it could be a single-page application, Blazor app, ASP.NET Web API or something else, and it communicates with microservices that validate the input, the prompts that would be sent to the models, and it could actually code many different models, maybe in certain order. Let's just say, for example, with cognitive services, it could extract text from a picture, then analyze the text, prepare some prompt for a large language model, and so on. Maybe let's just say that it analyzes a picture of invoice and then returns some useful information to the customer. That's a use case. Then we have orchestration layer that communicates with all the models. It might communicate with third-party APIs. It might communicate with some automation like Azure functions, logic apps, and so on. And then when we get all the results, we can pass it to another microservice like unified results aggregator and return the information to the customer. I'm not talking here about the different methods of communication. We could have event service bus, CQRS pattern, and so on. But we could decide that based on specifics. So we have the classic API gateway pattern, and I'm going to talk about the generative AI gateway pattern and zero trust architecture. So the classic pattern is we have client applications, then we have some API gateway service, like let's say Azure API management that might perform logs, route the request to the different microservices, to the backend, and so on, and manage the request pipeline. We can extend that with using AI tools, where we track the number of requests that come to the backend. We could maybe cache the request, some of the requests, and return information to the user. We could also monitor and log everything that is happening and perform reports. And a little bit about zero trust architecture. We have to implement some of the best practices. Everything is going using Microsoft Entra ID. We can use Defender for endpoint on endpoints. We could use tools like Microsoft Defender for Cloud to ensure that we have compliance with certain policies like NIST. Maybe Microsoft Sentinel, where we could deploy our own custom machine learning models, because Microsoft Sentinel offers some AI capabilities, but they're quite insufficient, so we couldn't develop our own custom machine learning models for analysis, for threat intelligence, and so on. And of course, there are some other defenses, for example, Defender for Office 365 and others. So a little bit about MLOps in security. What does an MLOps workflow looks like? Typical case, we may have a GitHub repository where we have the code where the model might be deployed as a file, or it might be developed somewhere else in another machine learning repository and deployed separately. But let's just say that we have a GitHub repository, then we deploy everything using Azure machine learning pipelines, where we train, tune, and evaluate the model. We deploy it to a machine learning registry, then we have a CI/CD pipeline, let's say DevOps or something else, where we have different environments, QA, product, and so on. We deploy the model to machine learning tool like Azure Machine Learning, and then we perform monitoring while using App Insight or something else, and based on the scoring of the model or some other information that is passed with, maybe on some errors that it returns and so on, we could trigger new retraining of the model. And here's how it looks a little bit. As you can see, we have the main DevOps pipeline where we can run the new code and perform unit tests. And we could prepare the machine learning model, then train it, execute it, register the model, then we could package it in, let's say, Azure Container Registers or Azure Kubernetes Service, then monitor it, lock everything that we monitor into, let's just say, in Azure Storage or something else, and based on some metrics, we could trigger another training of the model if it starts to deteriorate and starts to return us a lot of error information, error predictions. What are the best practices? Track model metadata performance using Azure Machine Learning Registry, automate the training and evaluation in Azure Machine Learning, link your CI/CD to pull the latest production-ready model, call hosted model endpoints from our API layers, track prediction drift and input anomalies and any other errors using services like Application Insights or others. And then automate retraining triggers. Here you can have different strategies. Let's say you can retrain the model once per day, once per week, or maybe based on some data like in this example here, and then connect the retrained model pipeline back to the deployment pipeline. Some bonus about AI security in critical infrastructure, which is the topic of my PhD. What you see here is the so-called PERA, or Purdue Enterprise Reference Architecture, where you can see how the architecture of, let's say, of a nuclear power plant looks like. On the lowest level, physical level, we have sensors and actuators that actually perform changes to the equipment. Then we have programmable logic controllers, PLCs, and other types of controllers. On level 1, then we have supervisory control, human-machine interfaces, SCADA systems, and so on. Then we have historians on level 3. On level 3.5, the so-called delimiter zone, we have jump servers and others. And on level 4 is the SOC teams and SIEM systems. So my solution that I'm currently investigating and preparing is focused on defending basically level 0 and level 4 by analyzing the sensor data and the network traffic. How it works. Let's just say that I have IoT devices that pass the information to an Azure IoT hub. And let's say I have some network traffic that is passed to Azure Event Hub. Of course, that architecture could be extended with the messaging infrastructure, with some defensive infrastructure and so on, but I'm focusing on the main process here. We pass all that data to Azure Digital Twins, which is a service that allows us to model the infrastructure of a given place like nuclear power plant or others. Then the data from the Azure Digital Twins we pass to Azure Databricks, where we normalize the data, clear the data, remove duplicates or missing information, and prepare the data in a format that could be passed for training the model. And here we have the pipelines and everything. We prepare the model, and then the model could be called from, let's say, an Azure App Service, where IT teams could see whether there are not any current attempts to perform different attacks on the infrastructure, or maybe the model could be used to generate some reports for senior management. And that's pretty much it. Some future trends about AI in cybersecurity that I've already talked in the presentation. There is a lot of investment in AI-powered threat detection and response. Of course, there is still a lot to ask because AI threat detection and response only works in specific cases for specific services at the moment. But there is a lot of money involved in here, so eventually maybe they'll come with some more general solutions. And though there are also some augmented cybersecurity threats, as I've shown in a couple of slides. I haven't talked about quantum-resistant AI security. As you know, quantum computing is slowly on the rise. Currently, some of my colleagues are testing some machine learning algorithms that could be executed on quantum-based computers. But basically, we still can't perform some serious attacks with quantum computing. But as you know, European Union has already launched some programs in order to develop and implement some algorithms which we can use for cryptography, so that they won't be so that quantum computers won't be able to break the current cryptographic algorithms. I've talked a little bit about cybersecurity as a service in AI. That's something that little by little would come to fruition into the future. That's the idea of big tech companies. They really want to sell a solution that could be used by cybersecurity teams. Of course, it won't replace the cybersecurity professionals. They would use that to maybe make some customizations to it, like in the case with Microsoft Sentinel, maybe add some custom models and so on. But that is coming to be the standard. And of course, AI-powered compliance, that's when the AI scans your infrastructure and makes suggestions about how to be more compliant with some policies like GDPR, HIPAA, NIST, and others. And some useful resources, some YouTube channels that I follow for some interesting things you can see here, and some books that I like to read. Zero Trust Security, application security, and so on. I want to emphasize on the book How to AI with Statistics, because it's very easy to generate statistical data nowadays, especially with some AI tools, and you should always check the information behind the statistics. I had some statistics on some of the first slides of this presentation, therefore never trust statistics blindly, and we're trying to check them. And that's from my side. Thank you for your attention, and here is my contact information. If you have any questions,